Welcome to my Caveman DIY channel, where I build projects that interest me, and I hope they will also interest you. If copied, make sure that all the proper precautions are taken so you don't get hurt. High voltages can be lethal, so sit back and enjoy the video. Thanks for watching. Okay, I'm about to test this coil. It's my prototype. I've made about 5 of these coils so far and tested them out in different circuits. This one's built quite a bit different than the other ones. I made it a little bit larger. The core is a little bit bigger. The mixtures of the core materials a little bit different. Right now I'm putting a sine wave. It's kind of looks like a square wave, but it's because it's clipped down here at the bottom. But I'm putting 24 volts or 30 volts actually to the MOSFET. So I'm going to turn it on, let you see the waveform. You hear it ringing. A waveform is right now that's about 500 volts from peak to peak, and this is the input. Of course, this is on a lower scale, so this is channel 1, this is channel 2 on the MOSFETs down here. Now watch what happens if I go up in frequency. Watch what happens. You have to get it resonant, so if you go up in frequency, you'll notice that the peak to peak voltage will go way down. As you increase, there's about half of what it normally needs to run at. If you bring the frequency down to about 2.5 kilohertz, somewhere in there, about 2 right there, it seems to be the optimal point. But so far it's working very well. Now all I need to do is finish making the top core, and then I'm going to wind another core on here, and then when that gets done I'm going to put a secondary top core on there, which will fit right here, and it'll have windings on it. And then I'll come back and show you what the results are. The purpose of this center coil is to create high voltage for, it's going to create about 3,000 to 4,000 volts, so we'll see what the outcome of that is. Alright. I started winding the first layer of windings on the center coil, and then I got the first few windings of the high voltage winding round on here. This is what it looks like. Now I'll get back to you. Okay, I got the center coil finished. I got the high voltage windings on here, and this is what it looks like. Still have a few things to do. I'll get back with you on the next one. I put windings, finished the windings. I put a coat of Teflon tape around it and some acrylic plastic. Next I'm going to put the top coil on and run a test on it and see how it works. So I'll get back with you with the results on that. Okay, here we go again. This is the bottom coil down here. This is the top coil here. This is the secondary. This is what I'm going to create the high voltage. It also has a very small amount of turns on it to run a DC supply, which runs this 24 volt motor. I have 24 volts going in, and it's set at right now at about 4.9 kilohertz. Now I want you to see that what this is drawing is 120 milliamps. Now this is the important thing. Pay really close attention. This is pulling 56 milliamps, but it's about half of what this is pulling. Now watch what happens when I load the motor. Watch the pulse here. I'm going to load the motor now. Okay, I'm pulling 209 milliamps right there and 140 milliamps on the primary. So what does that tell you? I'm actually pulling more out of the device just slightly, because it does drop the voltage down from 24 volts down to about 15, 16 volts. But when you load this motor, if you look at the waveform, see, it doesn't vary. It doesn't pull the cores down. So when I have to pull pretty hard, it hurts fingers, but when you force this motor into drawing current, you can get it to draw over 200 milliamps, but you still only have 140 milliamps going from the power supply. So I thought that might be a little bit interesting to you. I'm still not as happy. I think I can get it even better than that. But right now, if you take the voltage and the current that the output of this draws, and the voltage and current from the input to this coil that it draws, right now the COP is roughly about 1.05, so it's just barely over. So for you people out there that thinks that over unity is not a possibility, here's the proof. 24 volts in, 120 milliamps. 24 volts out, 56 milliamps under a load. 200 milliamps, only 140 milliamps, still draw. It did, you notice it did come up a little bit, about 20 milliamps is what it drawed. But to go up 20 milliamps on the input side and go up 200 milliamps on the output side, what does that tell you? These cores don't load at all. So this is a complete success, but the purpose of this device is not to prove over unity. I don't care about that. There's people will argue that point from here to eternity, but I have produced over unity with this machine. Now here's the thing. What this is for a secondary device that I'm building. So I'm building a high voltage circuit, and I'll come back to you and show you that. But I still think I can make this a little bit more efficient than what it is. So what I'm going to do is make another one of these, because I'm thinking instead of using regular graphite and ferrite cores and activated charcoal cores, I'm going to use actually some other different chemicals in there. And I think I can make this just a little bit better. So I'll get back with you with an update as soon as it's done. I decided to change this coil some. So what I did was I put a new core on it, or added the core, and I put 22 gauge on there to run the motor instead of using the same 24 gauge. So it now I need to wind the 26 gauge on here for the high voltage circuit, and then I could put it back in my machine and test it out and see how it goes. I rewound this, took it all apart, built a new one, so this is a new core here. And the reason why I did that is because the actual 24 gauge worked okay, but I think I can get a little bit better with 22 gauge on here as the first winding. This is a high voltage winding here, and that's what it looks like. Now this is just half of the high voltage winding. I'm gonna test this winding, and then I'm gonna probably add, this is going to be the center, I'm going to ground that, or put the centers to ground it, probably ground it, and then build a voltage divider for the high voltage. And so this is it. This is, I think, hopefully, this is my prototype. So that's it on this one. I took this off the front, and the reason why I did that, or I mean off the top, the reason why I did that is because I wound this with double windings, and I don't think I want to. I was intentionally going to run some diodes and recharge these batteries with it. I decided not to do that. I'm going to build a whole new top core
for it. It's going to be a little bit bigger around too. And that helps bring the primary current down. These are the batteries that I built. These are lithium-ion batteries. And there's 3 of them. I put them in series, so it's 12, 24, and 36 volts. And I could change that on my device to figure out which one works the best. So, okay, I'm going to reinstall this, and then I'll get back with you and show you how it's working. Alright, preliminary tests on this new top coil here is I'm running through just the bottom part of this. I haven't added the top part yet, but to the bottom part of this coil, it's pulling about 210 milliamps, something like that. And coming out of this, this center coil comes over to this to this bridge rectifier, and it's going directly to this motor. Now this motor's pulling about 57 milliamps, but when you load it down, it's not as good as it was before, but now you get about 180 milliamps. But the voltage drops from about 17 volts down to about 9 volts. So you got to consider you have a lot less voltage than what's going into this coil. So if you figure out that this has got 24 volts in and it's running 210 milliamps, well, you know, there's quite a bit of difference between the two. But the point I'm trying to say is if you watch this draw down, and this will get better when I put the top one on, but if you watch when you pull this core, when you pull the core down, you can see the top part of this waveform will go down just a hair. See it go down just a very small amount. Even if you load the motor all the way up to about 180 milliamps. See it, when I let go of it, see it. You can see it, but that's how much the core loads with this, which is amazing. Other cores would drop all the way down. This, I changed the composite from this core. I added a little bit of copper oxide in with it on the second layer. So that seems to improve it quite a bit. So I got a feeling that when I get this top core on, hook it all up, show you how it works, it'll be quite a bit over Unity. You know, and I'll have to tinker with it and mess around with it, get the settings right, but it's working good now. This is the back of the machine here. This is for battery pack number 1. This is for battery pack number 2. This is 3, but it's 36 volts, so I don't use it anymore. I just tied it off here, so it'd be out of the way. But I put 2 batteries here. These are 12 volts. They're lithium-ion battery packs that I made. And what I do is I just put them in here, like so. I try to put a ridge out here, so it will. Well, here this will work right. So I put the battery in like that. Put this battery in like that, and then I hook one up to one battery, and then I hook 2 up to the second battery, like so. Well, if I can get it in there. And then I hook a holding, a way to hold the batteries up against there so they don't fall out when I'm moving this thing around. So that's basically it. So got 12 volts coming in here, these 2 wires, and then you got 24 volt tap here and a 36 volts. These are in series. I'll show you in the front here. These are in series. I put this one in series and this one in series. So this is a ground. The 12 volt one comes in these 2 spots, ground and the hot, and then the hot goes to this one, bridges over to this one, and this is where the 24 volt ground goes in, and then it comes out here and goes in here. But this is the bridge for the 36 volt, but like I said, I don't use it. This is the output from the center coil here,
and it goes to the bridge rectifier, to the center point. And the ground of this capacitor, this is a 120 mic 450 volt cap, and the ground goes to here, and then I got a wire that comes around and hooks in to down here, under here, and that helps filter the output of this diode. And that's basically it. These are where the high voltage comes in. This switch is on the 12 volts. This switch is on a 24. So right now you can see 24 in there. Hope you can see 24 in there. It's not drawing any current because it's not turned on yet. But when I turn this switch off, the 12 volts, 24 volts goes away. So this is just a way to switch the two main coils on and off. The 24 volts comes from here, and it goes through this switch and up to the input of this. Okay, I've got this part of the machine done. I still have to build a high voltage, and there's another device that I want to build. This is the 12 volt, this is 24 volts. This turns the top and bottom coils on here. When I turn this on, you'll see the waveform come up here, and you'll also see the secondary waveform off of this center coil. It goes to the center part of these two diodes. Now I can't hook up the ground to the scope, because then it kills it, because the other ground is hooked up to this one over here. So I have to leave one end of the probe off, so it cuts half the signal off, so you only see half the waveform. But anyway, let me turn it on and show you what this is. I'm really quite pleased. This is turning out a lot better than I thought it would. Okay, this circuit here is, from the center coil is, you can hear it ring, but it's producing 20.59 volts. It's unloaded on this motor. That's 50 milliamps. Now here's what's interesting. The output from the 24 volts that goes to these two coils is pulling 100 and it varies between 140 milliamps and 170 milliamps. So now watch what happens when I load this motor to the current. This goes from here through this meter to the one side, from the other side to the positive. Watch what happens when I load this. See what happens to the voltage, and watch what happens to the current. I load it down to about 12 volts, and it's almost 500 milliamps at 12 volts. 500 milliamps at 12 volts. Now you see it loading down over here when I load it, the waveform that goes to this bridge. You can see it loading down, but look, it's still pulling 500 milliamps. And you'll notice that this pulse here is about 1500 volts. I got it going through a voltage divider so it doesn't peak out the scope. But if you notice, there's 13 volts, 12 volts that burns my hand. It's pulling so much torque. This does not load these coils. It will not load them. And you'll notice when I pull this motor down, look at it, current goes up. It actually doesn't go up. It's down to 120 milliamps. So now I can pull an easy 500 milliamps at 12 volts when I'm pulling 150 milliamps at 24 volts. So figure that one out. Alright, I did some calculations. It draws the 24 volts for these two coils here draws, right now it's drawn 130 milliamps. It goes up to 160. It varies. This fluctuates for some reason. I think it's because of the chemicals I put. The magnetic field bounces back and forth inside there. Now, if you calculate that out, 24 times the max that it pulls, the 1.6, it's 3.84 watts. However, if you load this motor down to 12 volts, there's 500 watts, or 500 milliamps right there. Over 500 milliamps. Times 12 volts, that's 6 watts. So what does that tell you? Any wise engineer will know. What I'm saying here is this thing produces twice as much power from the output as it does the input. It's got a 2-to-1 and a COP. It's got a 2 COP. Now you tell me how that's possible. Now I got some explanations for it, and I think what I'm doing is causing sort of like a
maybe a tornado effect of the magnetic field that goes up through this long core. And these two top and bottom cores overpowers this. So when this pulls its maximum power out, it doesn't affect these two, because the magnetic field is traveling in like a vortex up through these cores. And so you're able to get more energy because of that magnetic vortex field that you're building up inside there. Plus, I think, this is my personal opinion, I don't know, I could be wrong, but I think I'm tapping into 0 point on these two coils when they're combined together. So that's what I think. So again, it goes from the on-off switch through here, 1.4 amps through the back of here, into here it goes across this 10 ohm resistor, and through this coil, and through the MOSFET. And now, of course, this isn't accounting how much power that I'm producing from my little amp board, but it's only like 20 milliamps, and it's not including what it's causing, what I'm have to produce this waveform. But you could build a little 555 timer and stick on this, and the whole thing will probably pull less than 50 milliamps. So we're still way over unity. We're still over twice unity. And again, when I turn this off, you'll see this voltage drops to nothing, and and you'll hear it stop ringing. And this switch is 12 volts. It runs this little preamp down here. So if I turn this off, the preamp goes dead. So let me show you. Well, yeah, there it goes. Preamp went dead. Now, this actually, when you turn this off, this capacitor charges so much that this motor will actually run for a few seconds until this capacitor discharges. So, but with the 12 volts on, when you turn it off, the voltage drops down pretty quick. It doesn't drop down instantly, but it drops down pretty quick. But then again, that's it. It's 24 volts to run it. 110, it jumps up and down. 110 to 160, say, milliamps to run these two coils. And I actually think if I made this coil bigger, it would actually drop that input current down lower. The COP would even go up higher. But I'm really impressed. This is surprising to me. I'm not trying to prove over unity. I'm just showing you the results of what I've built. And what I've built is if you load the motor down, you really load it down hard, it goes over 500 milliamps. Voltage drop, I mean, you can get the voltage drop down almost to nothing if you stop the motor. Okay. It'll hurt your fingers. It's drawing there's a lot of torque in this motor. But anyway, that's my machine. Alright, that completes this particular video. In my next upcoming video, what I plan on doing is building a duplicate of this coil here, this set of coils, so I can show you how I build the cores and how I put the different layers inside each core that I build. So thanks for watching, and if you like this video, please share it, and when I get all these videos loaded, I'll get a YouTube channel, and if you'd like to subscribe, I'd appreciate it if you did. So thank you very much for watching.